Hey kids, as we've been talking about physical change and chemical change, states of matter, and we need to go back and realize that all of this, yes, once again, rolls right back into the water cycle. I think this may actually be the fourth time we've covered the water cycle, so it should be something that we're very used to. We're just going to add a little bit more in-depth things to it as we go through the water cycle and take a look at some different aspects of it that might go through. Now, as we remember from the other 3 or 4 times we've covered the water cycle, the sun is really what powers the water cycle. It's the catalyst that keeps the water cycle running. It's what gets everything rolling, and we will talk a little bit about that. The sun's heat through a process called radiation, which we'll be getting to really soon, conduction, convection, radiation, is something that heats up the water and it turns it from a liquid into a gas through a process called evaporation. Let's look at that. Actually, I need to go through, let me make sure I ever get liquid to gas. Let's look at this not only on the surface level, but at the molecular level as well. Now, when you add enough heat, so if I'm going to add enough heat, let me add it down here as well, to liquid water, it eventually changes its state and it moves from liquid to a gas. Now, what's happening with the molecules is you have these little molecules that are kind of bouncing around and rolling and flowing over each other. They start to pick up enough energy, and as they start to move faster and faster, they get far enough apart that the liquid water actually changes its state and turns into a gas. Now we know that these molecules and these molecules are the same water molecules. And what we just learned in chemical and physical change is if something changes but it hasn't changed what the substance actually is, then you have a physical change. So if we go back and take a look at evaporation, evaporation is one way that states of matter can change from a liquid to a gas, and that process is actually a physical change. And now we actually know what that looks like from the surface level, what we can see with our eyes, and what it looks like on a molecular level as well. And we know that we need to add heat. And we all took our notes, and we all have this awesome chart here. And so to go from liquid to gas, you add heat as evaporation, and to go from gas back to liquid, you're going to take away heat in something called condensation, which obviously we will get to here in just a moment. Just to repeat and kind of look at the slide itself in case somebody needs to take some actual like word notes. Some people the pictures make sense, some people the words make more sense. Evaporation is when water gets enough heat from the sun and it changes it from liquid to gas. That's why the puddles that are there will no longer be there. And we'll kind of get into what may happen in the morning as you're listening to this here in just a few minutes. But water in puddles, lakes, streams, rivers, oceans, everywhere there's water, the sun heats it up and it causes evaporation. Once we have added enough heat, which is also giving these molecules a little bit more energy to move around faster and faster, we also learn that once this happens, that these molecules don't stay at the ground level, that these molecules, when they turn into gas, actually go up into the atmosphere. And something very, very special happens as we go up, up, up in the atmosphere. We have another change that takes place. Now, all of a sudden, we have our gas molecules high up in the atmosphere. We have all of the energy where these are bouncing around like that. Hopefully you can kind of see my cursor's bouncing around super fast. And as they start to get cooler, these molecules actually start to get closer and closer together. And as they begin to get closer and closer together, they move from this to where the molecules are like this, and they are very, very close together. But they form very teeny, tiny droplets up in the sky, And when all of these get together, these little droplets get together, we know this process is called, from gas to liquid, is called condensation. Now, when condensation happens in the upper atmosphere, we have something that we like to say condensation is cloud formation. So we have clouds that form. Now, condensation doesn't always happen as cloud formation. We say that because it's part of the weather, one of our biggest units. We say that because it happens in the water cycle, which we're going to cover again, believe it or not, maybe 2 more times this year, cover it quite a bit. We know that even though these molecules were far apart and now they're close together, it's the same molecule, so we have a physical change that just happened. Condensation doesn't always happen in the atmosphere forming clouds. You may take a very, very warm shower, and when you get out, the mirror in the bathroom may look something similar to this. I hope the word condensation doesn't get written across of that when you're in there by yourself. That would be kind of creepy. But I like this. I had two of my girls were sitting on the bus in the winter on a field trip. Everybody was breathing really heavy, obviously letting out a lot of hot air. The hot air that we were breathing out actually has evaporated water in it as we breathe out. That water vapor got close to the windows of the bus and caused what we would say, it fogged the windows up. But if you look really closely, it's nothing but thousands and thousands of tiny little water droplets. And they wrote the word condensation on the bus window, which I thought was pretty awesome. Even though I don't want kids writing on the windows of a bus, I didn't want to get mad at them on that because they're doing science, which was pretty awesome. So condensation is yet another part of the water cycle that happens. And in that water cycle, it's still water. The whole time it's moving through, it's water. So it's all these physical changes. Now, when you have these teeny tiny little water droplets, obviously they get big enough and eventually they are going to fall back down towards the ground. And when they fall to the ground, we call that precipitation. Now, we remember rain, sleet, snow, and hail as precipitation. But let's stop on that precipitation of rain, sleet, snow, and hail, and let's focus on the sleet, snow. Forecast for tomorrow is for lots of sleet or freezing rain, and maybe mixed in there with a little bit of snow. So now all of a sudden, we are going to be looking at our molecules aren't this, but our molecules are looking more like this in sleet and in snow because they are solids and the molecules are very, very close together. And these molecules will stay very, very close together early in the morning tomorrow because the temperature is below 32 degrees. Now, once the sun comes up, and things start to warm up in the afternoon and we get above 32 degrees, something starts to happen. As we add a little bit of heat to these molecules, again from the sun, these molecules that are super, super close together start to move just a little bit further apart. And when they move just a little bit further apart, they start to change state and they move from a solid, like sleet or ice in the morning, even snow, and they move to a liquid. Now, again, we look at this on the molecular level, water molecule. Has anything changed as far as the molecules go? No, it's still water in all of the states, solid, liquid, or gas. It is still water. So we have another physical change, but we're going to call this process melting, and we're hoping that the melting point happens a lot earlier than it does later. I know that I need to be at the school so that I can work better and have access to all the things that I have at school. And if there's ice outside on tree limbs and on power lines, we have a higher chance of power going out, which is not good for any of us because then we kind of get behind on the things we had planned on doing today. But when we're looking at the water cycle, we've never really sat and talked about melting point being in the water cycle because we just briefly kind of gloss over the sleet, snow, and hail portion of it as we covered precipitation, but we never really talked about what happens when that falls. Well, tomorrow, possibility of it falling. And if it does, we want it to go through the melting point a lot quicker. And then again, once it melts, that will be water outside somewhere in puddles, and the roads will be wet and the sun will come out, and we will move from that to where we go right back to this process. And that same thing that fell as sleet that then melted will now go through the evaporation process. And then once we get through the evaporation process, we're right back to where things start to condense again. And we're pretty much going through that entire water cycle. So we have our condensation that we talked about. Skipping over that. Precipitation, tomorrow, you know, precipitation is anything that falls from the sky. And I think tomorrow we have a chance for 3 out of the 4. We could see rain, we could see snow, we could see sleet, which is also freezing rain. We could see all of those tomorrow. I don't think we'll see any hail, but hey, don't say no, it's 2020, you never know. But precipitation is how water makes its way back to Earth. Whether it's frozen or whether it's in liquid form, it's coming back down to Earth in one way, shape, or form. It just depends on the temperature of the atmosphere and of the ground levels around us as well. And I think that those things are important for us to talk about, and we'll get more into that when we cover our weather. When things like tomorrow, when it's sleeting, snowing, raining, whatever it does, it can't stay on the ground forever, because water eventually seeps into the ground, into these underground aquifers. Now, as we all know, especially those of us that have fallen on the playground over the last couple of weeks, our ground is very wet. The reason why is we've had so much precipitation that this infiltration down here and in the aquifers is getting full as well. So it's almost very spongy on the ground. And we don't have a lot of the water seeping down as far as it usually does, because the ground just can't hold that much more water right now. It's full. It can't hold a lot more, and that's why our ground is wet. But runoff is basically what happens when rain or sleet or snow or hail, and once the snow, hail, and sleet melt, it's going to run off towards things like rivers and lakes and things of that nature. And we'll get really into runoff when we start doing the actual water cycle during weather, is when runoff and infiltration and those things will become probably more important. Whoops. Collection's pretty easy. If the water collects somewhere, a pond, a lake, a river, a stream, ocean, a puddle, it's called collection. And eventually it does soak into the earth and becomes part of groundwater, but we've kind of filled that up right now. It's like the cup is full and just can't hold anymore. Groundwater is where water is stored in the ground. I know we've covered that. It's not been like a super official vocabulary word, but we've talked about that. And you can kind of see here, if this gets full, it kind of fills up to here, and then it makes this super soggy, which is pretty much where we're at right now. The water down here is just as full as it can be, which comes back up through here, and now the soil is like a big giant wet sponge that we're all trying to step on. So we've covered all these different ways that water can change in the water cycle, except this time we focused a little bit more on what it looks like at a molecular level. And we did that because now we're studying states of matter, and parts of states of matter that we studied is looking at the molecules of different things, and parts of states of matter was chemical and physical change. And we know that all the processes in the water cycle are going to be labeled as physical changes, because we're never changing the actual matter. It's water, whether it's frozen, whether it's liquid, or whether it's a gas. It's water in all 3 states, because if you were to see it on a molecular level, it's the same water molecules throughout. I hope this helps out a little bit as we move forward. Good luck on the quiz. I think you're going to do very well on that. You have all of your water cycle notes from my videos. You're welcome to use those on any of those that you need to. Good luck on that. And then we finish this up. I want you to work on your project. Try to get as much of that done as possible so that on Thursday you don't have a whole lot to wrap up at school, and we can move on and play some review games and get ready for our test on Friday. All right, kiddos, have a good one. Hopefully everything's going well for you. You're staying inside and staying warm, and keep on rocking it in science.